So this challenge we have ARIKA, which says in the prompt, the ARIKA ransomware group likes to look slick and spiffy with their cool green on black terminal style website. But it sounds like they are worried about some security concerns of their own. And we see here that we do have a zip file as well as the password being ARIKA with, again, a specific IP address that we have on the VPN. As many of you know, before I start anything having to do with a web challenge, I do enjoy looking at code first before we dive into what the vulnerability actually is on the specific web application. Let's see if we can find it on the back end before we try stuff on the front end. So I've already downloaded the script here, and we can see that there are a couple files. There's an app.py, docker, a flag.txt, requirements.txt, and then a bunch of static and template files. So whenever you see a flag.txt, when you unzip something, chances are you're going to want to look for SSTI or remote code execution. So we can head on over to code, which is just VS Code for short in the terminal. And this is going to spin up a VS Code instance for us. We go to app.py. We could see what is going on. So we see that the allow list is all of these commands, which there are 8 in here, and this is going to be a key element, and I'll explain that in just a second. Then we have the run command, which is not sanitizing any user input and is simply running the CMD from the run argument and then spitting out whatever text is within the output. In addition to that, we have another post, which is the exec command, and that's just taking in the command parameter, stripping it, and then checking to see if anything is a command. If it's not, and it does not reach this specific RE or ReGEX match, it's going to also fail and say that the command is not there. Now, where exactly does the vulnerability lie? Well, of course, we obviously see that there is a tech-c or /bin/sh tech-c with the CMD. So automatically off the bat, we know that we need to get remote code execution from this specific code. But how do we get to that function? Well, we could start looking at various different functions that we have in here. And we could see that if all the if checks are passed, we can then retrieve the run command function. And then it'll spit it out to us in JSONify format or JSON format. So we need to figure out a way to go about bypassing it. And to start off, we definitely cannot bypass these two because these are actual if statements, right? So if it's not within the command, then, or if it's not a command, let's say, it's going to give an okay and just say, hey, you have to try again. If it says clear, it's going to clear the entire terminal that we're looking at. But in this specific if statement, we do see that there is a regex match. Now, what exactly is this regex match doing? We can see here that there are 3 different parameters going into the regex match. So we see that it is a string that is going into, I guess, anything that's being allowed, the command that we're actually doing, and then the length of the allow list. Hey guys, so Future Evan here. After recording and uploading the video to the editor, I realized that I did not explain this vulnerability at all in the proper way. So here is the second time I'm going to try to explain this vulnerability to you so you have a better understanding about what to do. First and foremost is because the allow list has 8 within it, and we see here that the regex match also has a length of allow list, we need to figure out the length. And since we already know that it's 8, we need to find out which flag of regex works for this specific challenge. Now, to go about doing this, we can start looking at what kind of flags there are in regex. So if we look up regex flags for Python, we can see that there is going to be a bunch. So we have reignore, ignore case, we have reascii, reverbose, .all, multiline, etc., etc. And what we can do is, for instance, let's just do reignore case. We can come over to the terminal and we can type in Python 3, and we're simply going to import re. And what we're going to do is we're just going to print the int, and then we're just going to paste in that re.ignore case. Now, when you do this, you're going to see that a number appears. This happens to be 2, and we're trying to find the bitwise that is set to 8. So looking at it again, we can just continue down the line. So we'll try to do multi-line here, and we'll click on enter, and we can see here that this is now set to 8. So instead of something along the lines of saying, length is set to allow list, we can simply remove this and set it to re.multiline. And what this is going to do is this if statement is essentially going to check to see if everything adds up, as well as if there is a multi-line, so a /n. If there is, it's going to just break that out into an actual new line and then go about executing it. And what do I mean by this? So let's look at a visual here. If we do something like the payload, who am I, and then /n, and then ls, we can see here that this is just a string, right? And if this flag wasn't here, this is exactly what it would check. But because this flag is here, what it's going to do instead is it's going to remove our /n and make an actual new line. So now we have two different commands bypassing this regex match. So now instead of just doing the whoami command, if that succeeds, it's going to go over to the ls command and execute the ls command. I hope this clears things up. Let's get back to the video. So now that we have a little bit more of an understanding regarding this specific vulnerability, let's head back on over to our private IP address, which is 10.1.159 and then 39. We'll paste it on in to see what there is to work with. So it looks like the private IP address is not working. So I decided to click on connect within the Huntress CTF dashboard. And this leads us to the web application. So like I stated before, right, if we try to type in who am I, we could see that we're guessed. We try to type in ls, we could see that that if statement is properly checking and sending a help command. And then of course, if we do clear, it's going to clear the entire terminal for us. Now, because we know the solution, let's just try it out. So if we do who am I, tac n, and then we can try to do something like ls. When we click on enter, we can see that it still says run help to see valid commands. And you might be wondering, well, why exactly is that? If you have Burp Suite enabled and you head on over to your Burp Suite, we'll just copy this on over to repeater and we'll click on send once again. So something funky is going on within this request. Every time you do a request, sometimes if you're using JSON, if not all the time really, you're going to have two backslashes in place. And this is just escaping the backslash so that way you don't break the JSON code essentially. So if you remove this, so now it's only a single one, just like our original payload. If we click send, we could see here that we do have RCE onto the machine. And now what we could do is we could just cat flag.txt and we have the flag. So in this challenge, we're going to be taking a look at Sigma Linter, and it says, oh wow, another web app interface for command line tools that already exist. This one seems a little busted though. And here we do have a connect link. So let's head on over to it and see what we have to work with. And it looks like there is some YAML here, and we could just start clicking around and we could see here that it is just showing us some YAML. When I click on linked rules, we could see here that it says log source is a required property, but it does feed back some of the information that we need. So it doesn't look like these commands are actually executing at all from what I can see. We could try to do something like a quick cross-site scripting payload, even though it doesn't really look like there's any other users on this specific application. So I don't really know what XSS would do for us, but we could see here that there is some error messages, and it looks like it is Python error messages just based on found unknown escaped character C in Unicode string. So this kind of indicates to me that we are working with a YAML error or with a YAML interface on the Python backend. So what we could do is we could start looking at maybe some payloads having to do with YAML, because in Python, there is a vulnerability in PyYAML that allows us to perform remote code execution on the backend. So heading on over to Google, we could just type in something like YAML injection, and let's say something like payload all the things to see if there are any within payload all the things. And it doesn't really look like there is. Maybe we could try this, the YAML deserialization attack. And let's see if there are any payloads that maybe we can work with or do. And scrolling down here, it really does not seem like what we are after. Maybe it is. Well, let's keep reading and see if he has a specific payload having to do with maybe remote code execution or something along those lines. So we can see here that all he done was a deserialization data on the YAML.load. And when this deserializes the data, it does some funky stuff on the back end. So let's just continue down the line here. And let's try this payload here. So This is just time.sleep, which is using the time module. And we could see if our web application does time for 10 seconds. So when I click on rules, it does look like it is slowing down by 10 seconds. And then it gives us an error message. Now that wasn't really 10 seconds. It says network error. But if we do it for, let's say, 2 seconds, and we click on link rules, we could see here that we eventually do retrieve something back after 2 seconds, and this just gets set to null. So we already know now that there is some form of remote code execution or Python deserialization attack through the YAML, but how do we go about finding RCE? And let's continue down and just see if this person does have anything for us. And says here that we can use subprocess.popen. So we could try to do something like this, and I guess this is just going to do an ls command. So let's try this out and see if this works. So we'll do link rules, and it doesn't really look like that does work. However, we can see that there is a pickle error, means that it's doing something with serialization or deserialization on the back end, because that is what pickle does. So we can keep going down just to see if there's any other payloads that this person has. And if not, maybe we'll have to try a different blog here. So let's just keep going down and taking a look. And we could see that there really isn't a whole lot having to do with the Python deserialization attack that we're trying to do. But now that we know that it is called YAML deserialization, what we can do is we can modify our search a little bit. So YAML deserialization. And then we could try payload all the things just to see if we can get anywhere with payload all the things. And here we do have Python deserialization. Here's that pickle.loads that we were talking about just previously that we saw the error for. And we can see here that it does have a few options. So we could try to do something like this, which basically allows us to use the subprocess and then the check output function of subprocess. And then we'll supply it the arguments here. So copying it on over to the website, we can click link and we can see here that we do have remote code execution. So looking through some of this, we can see that there is a flag.txt here, and we could just do something along the lines of cat. And then inside of the next quote, we could do flag.txt, and that will give us the flag for this challenge. So this challenge is called emotional, and it says, don't be shy, show your emotions, get emotional if you have to, and uncover the flag. We see here that we do have a zip, and we also have a connect button. When we go over to the connect button, we can just see that it is still spinning up. But in the meantime, we could take a look at the source code. So this looks to be a JS application, so probably a Node.js application. And let's expand it just a little bit. So looking at it, it looks like we only have two specific endpoints, the post to the set emoji, as well as the get. So the post simply gets the request body and then submits it over to JSON. And then the get is whenever you access, I guess, the slash endpoint, it'll read these specific files to showcase the template that we're working with. And then it'll try to render the HTML through whatever emoji that we go about setting it. Now, again, there is no user sanitization on this specific box, indicating to me we're going to need to get remote code execution. In addition to that, we also can see that there is a flag.txt confirming our suspicion that we will need to get remote code execution onto this machine or some other form of vulnerability. Now, whenever you see something having to do with render HTML on a backend, chances are you're looking at a server-side template injection vulnerability. Now, this is not Python. This is a different form of templating, right? So we're going to use the less than greater than with the parenthesis sign on both ends and then putting in whatever payload we want to over here. We can go about doing this, heading on over to, again, our good friend payload all the things. We could do SSTI. And then we'll just type in something like node and see if maybe anything shows up or JavaScript. So let's see what happens. And it looks like this is using EJS, which if we go back over here, we can also take a look and see that it is using EJS. So if we scroll down a little bit, let's see what kind of payloads it has. And it doesn't really look like there's all too many payloads to work with. So we could try just to see what is going on here. And we could try to come up over here and just do something like EJS and then SSTI payloads and see if anything shows up. So we can just start looking through and seeing if there are any payloads for this specific vulnerability. And we can see here that we could try to do something like this. And you can see here that it is doing an equal sign as well. This is just another way to go about doing EGS template. So we can click on update and we can see here that the emoji was updated. So we're going to need to use Burp Suite to actually modify this specific parameter. So let me quickly find that endpoint. So finding the endpoint, we can see that there is the Unicode stuff here, which just does the emoji. We're going to replace that and put our own payload in here. Do a Control U to encode everything that needs to be encoded. Click send, and we can see here that our payload does show up here. When we try to reload the page, we could see that nothing actually happens. So we could try a couple of other things and a couple of other payloads. First, we could try is just removing that equal sign to see if that works, and let's reload the page again, and that also doesn't look to be working. We could try to do something like removing the spaces now. So if we try to remove the spaces and we click on send, we can see here that we have a very small payload without any spaces or anything new, and we see that there is nothing showing up here. So let's head back on over to Google, and we could try to do something like remote code execution and see if the Google AI can find anything pertaining to remote code execution, even though I don't think it will show those kind of payloads to us, or maybe it will. I really don't know, and it looks like it doesn't. So we're going to need to find someone who has this payload on hand. So after adding the node within our Google search, we can see that there is a vulnerability which was critical called CVE 2022-29078 in the EJS version prior to 3.17, which allows remote code execution through manipulating internal options via the view options parameter in render file. And the payload that we can go about using is something like this. So inside of this exec sync, we could just put in a command that we want to work with. So let's try this payload inside of our Burp Suite. Head back on over here, and we'll just add in the equal sign once again. We'll paste this on in, and we'll remove the space there. And instead of doing nothing, we'll just try to do something like ls and see if that works. So we'll come back over to Get Emotional and refresh the page. And we can see here that nothing again does happen. Now, this is the working payload that I got working on the actual CTF. So I'm a little bit confused as to why it is not working. Let me try to add a semicolon in the back and remove maybe the URL encoding. And let's see if that works. And maybe we also need to add something like toString, which is just a way to get it to show up as a string parameter. So let's try this. Let's click on send and reload the page. And for a split second, we did see that it was working. So let's try to go to page source and see if it does show anything within it. And here we can see the flag.txt as well as all the different kinds of files that are on this server. So we already know that this now works, and we see here that this is where the SSTI is being prompted. So we can come back over to our Burp Suite, and instead of doing ls, we could just do a cat flag.txt. And again, we will just put a plus sign there for URL encoding. When we click on refresh and we scroll down a little bit, we see here that we do retrieve the flag. So this is the final challenge for the web category of Huntress CTF 2025. If you have enjoyed the video so far, please let me know in the comment section down below, and don't forget to like and subscribe to the YouTube channel for more content similar to this. This is called Flag Checker. We've decided to make this challenge really straightforward. All you have to do is find out the flag. Just make sure not to try any of the security controls, trip on any of the security controls implemented to stop brute force attacks, and this does require a VPN connection apparently. People were restarting the instance repeatedly, and I was doing the exact same thing for this specific challenge. This is one way to go about doing it. It's the very long way to go about doing it, but you can do it that way. Nonetheless, we're going to do it the proper way, which is the intended way of doing this challenge. So heading on over to the connection, and we could try to do first the private IP address, but they have not been working today. So in the meantime, while that's trying to load, we'll just click on connect, and we can see that it says flag verification. Tell me the flag and I'll let you know if you're right or not. And here we have the token, and it says just supply the flag. So we could just try to supply something like this and see if we get anything. And it says not quite. And it looks also like inside of the submit endpoint, there is a flag parameter that has our specific flag here. So we can head on over to Burp Suite and see exactly what is going on in the backend. So looking at it, we could try to see what exactly is going on. When we do it and we click render, again, not quite. If we look at pretty, we could see if there's anything inside the source, which there is not. So what exactly can we do? So the first thing that came to mind when looking at this challenge originally on the CTF was this header here, the X response time 0.5. Now what this is doing is this is checking to see if a character is correct or not. And if it's correct, the time goes up. If it's incorrect, the time stays static. For instance, if we try to do an F here and we click on send, we can see that it's 0.1 seconds as the response time. If we do an L, we can see that it's 0.2, so on and so forth. Now, if you continuously spam this quite a few times, we're going to end up getting blocked, and it says stop hacking, your IP address has been blocked. Originally, what I tried to do is try to bypass this by doing a bunch of different things like Tor VPNing to see if my IP address can change, and then me actually being able to continue the brute force. This is not a real IP checker, right? This is just simply saying, hey, you're not allowed to use this port anymore. Try to find something new. Now, we can assume that we're going to be using Python or Node.js or something along those lines. And most of the time when you're dealing with web app challenges, they're going to be on port 8080, 8000, 5000, and 3000. So if we try 3000 on the port, we can see that it fails to connect. But if we do try 5000, again, on the private IP address, because this challenge does not really work all too well, like it says in the challenge description, if you use the connect button. But looking at port 5000, we could see here that it's the exact same challenge. And if we try to do the exact same thing, so flag, we could see that it does say X forwarded for header is not present. This is a basic vulnerability having to do with rate limiting bypass using the X forwarded for header. So if we just copy the X forwarded for into Burp Suite, we'll try to find this specific endpoint here. So let's copy this on over to repeater. And let's modify this to say X forwarded for, and we'll just do 1111. When I click on send, we can see here that we are retrieving the response time once again. If we continuously click send, after a while, we are going to get rate limited once again. So let's just wait for that to happen. And we can see here it says stop hacking, your IP address has been blocked. But now all we have to do is modify this IP address one time, click on send, and we now have access back to the application. Now, this will take a while to try to brute force because, again, we are looking for an MD5 hash. That's 32 characters, A through F, as well as 0 through 9. So we aren't going to start trying to brute force that and bypass that because we really can't manually. We need to use a Python script. And I've developed a Python script that does just that. So let me get it and let me show you what it does. So looking at this solve.py script, all we have to do is supply that IP address, which is the 10.1.216.37. And then what we're going to do is we're going to try to originally start out with the flag with the squiggly bracket. It's going to put the IP into what we need to do and then set the parameter to whatever with the header as X forwarded for. And that's going to also return the X response time. And it's going to start by exploiting it, doing a while loop. So if the flag does not equal 32, it's going to continue. And it's going to check by doing an enum on the characters. So this just essentially grabs a number as well as the character. It's going to supply it the flag plus whatever character we're trying to brute force at that specific time, making sure we have unlimited IP addresses so that way the script never stops. And it's going to continuously try. If it does work, it's going to check to see whether or not the time has increased a little bit. And if it did, it's going to say that the next character was found. And once it hits the length of 32, it's going to say that the flag was found. So coming over to the terminal, we could just come here and we can type in Python 3, solve py, and then we're just going to do the 10.1.216.37. And we're going to let this run just a little bit, and it may take 5 to 10 minutes, depending on how slow the server is to connect. But I'll get back to you once the script is done. So due to lack of resources on the web server, because the CTF has since ended, I was unable to perform the script due to just the processing power as well as the server resources. So this is what the output would look like on the script if you did run it, and we could see that we do retrieve the flag for flag checker. But all in all, if you did enjoy this web application video, please let me know in the comment section down below, and please like, subscribe, and I'll see you in the next one. Take care.